So here we go. How do we solve linear quadratic systems algebraically? So we have our quadratic definition, right? One of the terms has to be squared. That's a quadratic equation. Okay, here's the general form. Right? As long as a doesn't equal 0, it's a quadratic, as long as you have an x squared. Okay, so we have a couple different instances here, things that are going to be happening. So we have two possible solutions in this first graph here. All right, and you see those solutions where they actually intersect. So the intersection points, okay, are the solutions. So this is one option. Your line hits twice, hits the parabola twice. Another option is your line can only hit one time. That's where you would only have one solution. Okay, the ordered pair 2, -6. And then the last type of problem is where you have no real solutions because the line, it just misses the parabola. Okay, so we have those pictures there, so you can think about that as we're solving, because we just may encounter those cases where it doesn't hit, or it hits once or twice. Okay, usually hitting once is going to be the answer, possibly twice for the regions, not usually the 0 times. Alright, so let's take a look at this first problem. We're going to solve it. So solving this system of equations algebraically. Well, just like we've done before, okay, you need to set them equal to each other. Okay, they're both equal to y, so we can set them equal and write x squared minus x minus 6 equals 2x minus 2. From there, we are going to get everything to one side, so subtract the 2x and add the 2. We end up with x squared minus 3x minus 4 equals 0. Okay? From there, we can factor it. It's not going to be too bad. So we get x and x, 1 and 4, it's a minus 4 and a positive 1. So x will equal -1, and x will equal 4. But you're not done, and a lot of people stop here and get a 2 out of 4, and that's, almost something to cry about as a math teacher. So, the next step, find the y values by substituting each value of x into the linear equation. So you choose the linear equation because that's the easier one, okay? You could choose the quadratic, it would still work, but, why choose crazy? Anyways, so y equals 2x minus 2, y equals 2x minus 2. I have two x values to plug in. The first one is 2 times -1 minus 2. That gives me -4. The next one is y equals 2 times this 4 right here. So 2 times 4 minus 2. So y equals 6. That gets you 3 points on a Regents exam. And then what you need to do is actually write them as ordered pairs. So your answer is going to be the x and the corresponding y. So the x value was -1, the y value was -4. So you have to write -1, -4. Same for the other one. We have 4, 6. Those are the answers. Put in the brackets if you so choose. You're good to go. Now we want to do a check. Use the calculator to come up with our answers. So you go to your calculator, you type in the two equations, and you make a little sketch. So I have my calculator right here. Make my little sketch just so I can show that I have it. There is the first one. Here is my next one. Look at that. They do intersect twice. The first point of intersection. Who would have thought? That is -1, -4. This point of intersection, go figure, is 4, 6. Okay, and we've got a nice little check done. If the check only showed one point of intersection, we would reject one of them. Okay, or 0 intersections. That's kind of how that goes. So let's jump on to another problem. We're all checked and ready to go. This question, a little more challenging. So you have x squared plus y squared equals 25. Okay. You need to understand that that is a circle, all right, with the center at 0, 0, all right? You should know that already. So 0, 0 because they're not adding or subtracting anything to the x or y. And the radius is 5 because you squared 25. But anyways, we got to go ahead and solve this. So we're going to use substitution and plug it in. So if we first solve for y equals in this equation up here, we will get y equals 3/4 x. So we divide by 4, we get y equals 3/4, and then the x. So now we're going to make a substitution, which means this problem is getting really weird because it's got fractions, and no one really likes fractions, but we can still make a substitution. So it's x squared plus what used to be y squared equals 25. And in place of that y, we're going to put what we know y is equal to. What we know y is equal to, right up here, 3/4 x. So we take that and square it. Well, that just means square the fraction. So you have a calculator that you can totally use. 3 squared over 4 squared, you really shouldn't need it. But anyways, you can totally use the calculator to come up with it, or do it in your head. 3 squared is 9, 4 squared is 16, x times x is x squared. And we get that equals to 25. Okay. So now we need to add these lovely fractions. So to be able to add them, they have to have a common denominator. Although, again, you have a calculator sitting there right in front of you. You can totally do the 1 plus 9/16 and get an answer. I'm going to simply change this to a common denominator. So I'm going to say, you know what? 1 is the same as 16/16. Hope you all agree. So now I can take and add those. If you type that in the calculator, though, 1 plus 9/16, you'll get the same thing that I'm going to get right now, which is 16 plus the 9. 16 plus the 9 gives me 25 over 16 x squared equals 25. Okay, I like multiplying by the reciprocal to get the x squared alone, so I'm going to do 16/25 now. 16/25. It's convenient because it cancels the 25 and the 16, giving me x squared equals. And then over here, it cancels the 25s. I have 25 on the top and the bottom, and I'm left with 16. You have to be careful when solving this last part. When you square root to get rid of a squared, say it a million times, people always forget. Alright, when I square root 16, it is not going to just be 4, because 4 times 4 is 16, yes, but so is negative 4 times negative 4. So we have to add the positive and the negative in front. So it's positive 4 and negative 4. And again, those are only the x values. All that work, and you've got yourself 2 points on the regions. So take your easier equation, which is the linear equation, even though it's got a fraction, and people are afraid of those. We're going to plug in positive 4 and negative 4. So y equals 3/4 times the positive 4. Equals 3/4 multiplied by the negative 4. Well, that's pretty easy. If you put this 4/1, the 4's cancel and you're left with y equals 3. If you didn't know to do that, you still can use a calculator, type in 3/4 times 4, and you will see that it is 3. And then you multiply it by the negative 4. Again, the 4's cancel, but you're left with a negative 3. And again, this gets you 3 points. If you would want to get the full credit for this question, you have to write them as ordered pairs. So I have 4, 3 is one answer, and negative 4, negative 3 as my other answer. Put them in brackets, and we're good to go. One part of this one is graphing it in the calculator when you don't have a calculator in front of you. Anyways, the first one we said was a circle with a radius 5 and at 0, 0. So I'm going to try and draw the world's... Oh, that is just so ugly. Let me hit back and try that again. Alright, ready, round, yep, and that's a little better, but still pretty ugly. We're going to pretend that is correct. And then we have the line y equals 3/4 x. Where's that supposed to go? Right about there. Okay, so we see that it intersects here and here. Find the points of intersection in the calculator, and yep, conveniently enough, this guy over here is 3/4. I'm sorry, 4/3, I apologize, 4/3. And this guy over here is -4, -3. So they did intersect correctly. Now how do we get this in the calculator and get this to work? Well, we need to first obviously add a new window. Alright, and then you're going to go to the graph. You're going to hit the menu button. You're going to hit option 3, which is entry/edit. Then you're going to go to 2 instead of 1, which is function. You're going to go to 2, which is relation. And all relation lets you do, we'll talk about it in class I'm sure, but all relation lets you do is type in an equation as is. So now you can actually type in x squared plus y squared equals 25. You don't have to solve for y equals, which is, kind of nice just to be able to type that in. Anyways, type it in, then you can find the points of intersection, and we're good to go. All right, last fun question. Put that in quotes, fun. Anyways, get y equals again. So I'm going to add the y over and subtract 6 at the same time, so I get x minus 6 equals y. And I'm going to use that equation. I'm going to make a substitution and put that in place of the y here, which is where this problem gets to be fun. Yeah, real fun. So we have an x squared plus a something squared equals 26. Now that something is supposed to be y, but we're making a substitution, and in place of y we're going to write x minus 6, which is what makes this question so fun. So we have to FOIL that out by writing x minus 6 multiplied by x minus 6. A lot of you are to the point where you can just do that in your head. You don't have to do it in 2 steps. So the minus 6 and the minus 6 makes minus 12x. Negative and negative makes positive 36 when you multiply it. Equals 26. Subtracting and combining like terms, so I get x and x makes 2x squared minus 12x. And I subtract 26 and get plus 10 equals 0. People probably start to get a little bit nervous right now when they see that 2x squared, but this is not a tricky try. Okay. Take a 2 out, and we're left with x squared minus 6x plus 5. From there, we got to factor it. Trinomial factoring. X and x, probably minus 1 and minus 5. Seem to work. So we get x equals 1, x equals 5. You had better not write 2 equals 0. It totally does not. The trick is, the rule is only things with an x, a variable, gets that equal to 0. Again, you've done half the problem, or at least you've gotten half the credit. So now we got to take and plug it back in. Again, choose the easy equation. So y equals x minus 6. So y equals 1 minus 6. So y equals negative 5. And then the next one, y equals 5 minus 6. So, again, the answers that we're going to have would be x is 1, y is negative 5, and then x is 5, y is negative 1, and we're good to go, except we probably should have done our check. So, the check. Probably a good idea to do the check before you actually write your answers and put them in brackets. If one of them doesn't work, you're going to have to scribble it out now, but hey, that's okay. Hopefully they both work. So, go to the calculator, you type it in, got to do your relation, x squared plus y squared equals 26. It is centered at 0, 0, but the radius this time is not 5, it's square root 26. Very, very poor graph. Then the equation y equals x minus 6, it's going to be right over here, so minus 6 going up. It is going to cross twice, thank goodness, and it does cross at 1. Well, that's supposed to be 1, negative 5, it's a bad picture, and it crosses at 5, negative 1. So it does work out. Now, as I said at the beginning of the video, okay, if on the regents they don't say, it doesn't say on this question, only an algebraic solution, it does say algebraically, never mind, but if it doesn't say only an algebraic solution will be accepted, or solve algebraically, I would totally type this in the calculator and solve it like this. Okay, you have your x, your y, as long as you label your equations, okay? You go through, label your points of intersection, write your answers, just like we did here. You get full credit, and it's very, very simple. But again, if it doesn't say, so if it says only an algebraic solution is accepted, or solve algebraically, and you decide to solve it this way, you still get usually half credit, 2 out of 4. But I'd much rather you get full credit and solve it the right way. But if they forget, solve it graphically. So your summary should probably talk a little bit about maybe, what you have to solve, maybe saying, solve for y equals first, make a substitution, solve a quadratic, take the x's, plug them in, things like that. Okay, you don't want to skimp on the summary. Make sure it's a nice summary. Thanks.